Now this video is all about the distance, finding the distance in the coordinate plane. And so your learning target is I can use the distance formula and the Pythagorean theorem to find the distance between 2 points. Let's get going. We have a formula and a theorem to talk about before we get started. The formula is called the distance formula. And what you do with the distance formula is you take the x values of 2 points, so x2 and x1, and you find the difference of those. And once you find the difference, you square the difference of those x values. And once you have that, you add that to the difference of the same 2 points, but their y values squared. Okay? And you're going to add those two together. And once you add them all together, then you can find the square root of that. And that square root, once you find that, that will give you the distance of whatever line you are trying to find. The distance between 2 points. Okay? Now the theorem is much like it. It's called the Pythagorean theorem. And I think most of you guys have probably heard about this theorem. But it pretty much says that we have a squared plus b squared equals c squared, where a is the side of one side of the right triangle, one line that's coming off of the right angle, plus b squared, where b is the other side of the right triangle, the other line that's coming off of that right angle. And that will equal whatever the hypotenuse is, or this value of c, the distance between this point and this point, whatever the distance of that squared. And so you would end up having to find the square root of that. But we can tell, if you look closely, x2 minus x1 squared, that's just a. y2 minus y1 squared, well, that's just b. And that's going to equal the square root of whatever all that is. So these formulas are pretty much identical, but we can see it in a couple of different ways. So let's go to the key concept here. So two different things that we're going to do real quick. When we're asked to find the distance of a line segment using the distance formula, the first thing you want to do is identify the x and y values. What are the x values of the two coordinates you're dealing with? What are the y values of the two coordinates you're dealing with? Then, after you do that, you need to plug the x and y values into the equation and solve. Make sure, this is very important, make sure that x2 and y2 are from the same point. Okay, you can't have 2 points and take the x value from one point and the y value from the other point. It needs to come from the same point. And same thing, x1 and y1 are also from the same point. Okay? Now when we're solving a problem with the Pythagorean theorem, we first need to form a right triangle. We're given a line in the coordinate plane. We need to form a right triangle from that line segment that's been given to us. Then, once we've done that, we need to find the value of length of the two sides coming from the right angle. Wherever that right angle is, it's the two sides that come from that angle. And the last thing we need to do is use the formula a squared plus b squared equals c squared. Plug those values in for a and b that we found in step 2, and then solve for c. Alright, let's do some examples. Alright, example 1 asks us to find the distance of FG, that's this line right here, and JK. That's funny. JK, which is this line right here. And then we need to determine whether FG is congruent to the JK. Alright, so first thing I'm going to do is I'm going to remind us of what the distance formula is. Remember, the distance formula is the square root of x2 minus x1 squared plus y2 minus y1 squared. Okay, so we're going to let's go ahead and first find FG, and remember the first thing we need to do when we're using the distance formula is to identify the x and y values. Okay, so F is at the point 1, 2, G is at the point 5, 5. I'll go ahead and do J right now is negative 4, 0, and K is at negative 1, negative 3. Alright, so I know what each coordinate is. And the second thing is that we need to plug the x and values and y values into our equation and then solve, making sure that we keep x's aligned, or x2's aligned with y2's and x1's aligned with y1's, right? Okay, so let's do FG first. The distance of FG, line FG. And we know that's going to be the square root of x squared, which is, x2, which is 1, minus x2 minus x1, so 1 minus 5 squared plus y2 minus y1, which we started here, so we need to start here again, to minus 5 squared. All right, we're going to take the square root of all of that. So now it's just kind of solving, doing some math here. And we know 1 minus 5 is a negative 4 squared, plus 2 minus 5 is a negative 3 squared. Negative 4 squared is 16, plus 3 squared is 9. And if we do that, we get the square root of 25, which we know the square root of 25 is just 5. And so that is the distance of line FG. Okay? So we found the distance of line FG. Now we still have to find the distance for JK. That's so funny. Oh man, stop laughing. It's funny. Even though you're not thinking it's funny. Okay, so x2 minus x1 is negative 4 minus negative 1 squared. Plus 0 minus negative 3 squared. Almost running out of room. Okay, so we have negative 4 minus a negative 1, and remember when we're subtracting a negative, all we're really doing is adding those two values. So negative 4 plus 1 is negative 3. We have negative 3 squared plus 0 minus a negative 3, subtracting a negative means we're adding. We have 3 squared. We can already see something's going to be different. 3 squared is 9, and 3 squared is 9. Sorry, negative 3 squared is 9. And we get the square root of 18. And there's no number that kind of goes into 18 evenly, but we do see that the square root of 18 and the square root of 25 are very different, right? And so we can therefore say line FG is not congruent to line JK. All right, example 2 says a baseball player throws the ball from first base, this is first base right over here, to a point located between third base and home plate, and it was 10 feet from third base. So we're looking at some point in between here, and it was 10 feet. And if we count out all the little dots here, we'll see that this is the point of the throw. It went from this point all the way over to this point right here. Okay. Using Pythagorean theorem, what is the distance of the throw to the nearest tenth? All right. So we know that when we're dealing with the Pythagorean theorem, we first need to make a right triangle out of these 2 points that are given. Okay. So we're going to go ahead and connect these dots here first, and we know that the right triangle, sorry that my hand's so close, can be formed right through here. And we know that here is the right triangle, or right angle right here. And we know that this distance right through here is from 0 to 90, so this is 90 feet. And this distance to all the way up here, remember this is just 10 feet, so this has to be 80 feet, right? Okay, so we're going to use Pythagorean theorem, and remember Pythagorean theorem says a squared plus b squared equals c squared. And we're trying to find the distance of this, which we're going to call c right here. All right, so let's plug in some numbers. We're going to plug in 90 squared plus b squared is, or 80 squared, equals c squared. Okay, now this is just some math now. Okay, we know 90 squared, we know 9 squared is 81, so 90 squared is going to be 8100. 80 squared, 8 squared is 64, so we know that's going to be 6400, and that should equal c squared. All right, now we just need to add these two together, and we're going to do that right now live, and we end up getting 14,500. It's equal to c squared. Wow, that is a big number here. Remember, the opposite of a squared, in order to cancel out something squared, we have to use the square root of that. We're going to find the square root of both. We know that on this right side here, the square root of something squared is just whatever was on the inside to begin with. And the square root of 14,500, I don't know that. Let's use our calculator here. 14,500, and we see that is 120.4159458. And if we look, remember it says to round to the nearest tenth, which means that our answer would be 120.4 feet. That's a long throw. All right, hope you enjoyed this, and good luck on the practice.